everybody, it's Jeff Lantosh at Koury Engineering here again, and thank you for joining us on another Ask Jeff segment. We were recently asked, what is a maximum density test? Maximum density test is probably one of the most common tests that we perform as a soil engineering firm. Specifically, there are three types of max density tests. We're going to talk about that a little bit today. That's the ASTM D698, which is known as the standard proctor, the ASTM D1557, that is the modified proctor, and then the California 216 test, that's the Caltrans test. I would like to mention that there are significant differences in those three different tests. The biggest differences in the way that those are performed are the weight of the hammer that's being dropped, the distance that they're being dropped, and in the California 216 test, it's just an entirely different looking mold and everything. So today we wanted to focus on the ASTM D1557 test, Type C method. So Marcelo, he's filling this mold up here. This is what's called a Type C mold. This being a crushed miscellaneous base. You have different types of methods. You have the A, B, and C method. Aggregate bases are done with the Type C method, and what that consists of is filling this mold in 5 layers, and then we're going to drop a 10-pound hammer on it. It's going to spread around all the way around here across the surface of the mold. Drop the 10-pound hammer from 18 inches high 56 times. Marcelo? Looking for you guys, we actually have some examples of max density curves here with us today. We're going to go ahead and compare them here in a little bit. Kind of wanted to explain the process of what we're doing here. The way that we determine the maximum density and optimum moisture of the soil is, this was done, this is also an ASTM D1557, but this is a Type B method. This consists of a 10-pound hammer, 18 inches, 25 times over the soil. We're going to do that at different moisture contents. And so what you can see here, we call these points on the curve. This first point was done at approximately 10% moisture. And when we do that procedure of dropping it 25 times dropping the hammer 25 times, it gives us a density roughly 111 pounds per cubic foot. From there, we're going to add a little bit of water to the material. You can see now we're at roughly 12% moisture. We're going to do that same procedure again, drop the hammer 25 times from 18 inches, and that's going to put us a little over 112 pounds per cubic foot. We're going to do that same procedure again at slightly under 15% moisture. You can see it's kind of starting to form a curve here. What happens from there is our lab technician will then go ahead and add a little bit more water for the next point. Follow that same procedure. This one is approximately a little over 16% moisture. And you can see the curve actually drops. The point is lower than this point here. So what we're trying to determine is that where does the curve peak, because that's our maximum density. And then not only where does the curve peak, but at what moisture content does that curve peak. So you can see here the final results. Once we do our calculations, the maximum dry density of the soil was 115.7 pounds per cubic foot with an optimal moisture of 13.9%. What that translates to in the field, if the technician is using the incorrect max, if they're not able to identify the soil correctly, that's the difference between passing and failing tests. So when you work with Koury, what you're going to get is experienced technicians who know the difference, and they're able to match the soil description to the maximum density, saving you money.